Okay, so then this problem is going to be factored by grouping, and that means that I have to rearrange these in such a way that I can take out the greatest common factor. So it's all done by trial and error. But when I was working the problem out, I said, okay, well, I'm going to group the first two and the last two and see if it works. And it just so happened that it did. 5x cubed plus 4x squared, both of these have an x squared in common. And if I factor out the x squared from the 5x cubed, that leaves me with 5x. If I factor out the x squared from the 4x, that leaves me with a 4. With these two terms over here, I noticed that they both had a negative in common, so I factored out a negative 1. And when I factored out that negative 1, I have to think, okay, negative 1 times something is a negative 5x. That would be a positive 5x. So that's my missing factor. And then a negative 1 times something is a negative 4. Well, that's a positive 4, because a negative 1 times a positive 4 is a negative 4. When you get to this point right here, okay, this is factoring by grouping. And the reason why it's called factoring by grouping is because you want to group them and then end up factoring out something that they have in common. Here, I really only have two terms. I have this one, and I have this one. Between these two terms here, they have an entire quantity in common, meaning the 5x plus 4 and the 5x plus 4. So what I'm going to do is I'm going to factor out. Those were my intentions to begin with, because that's how you factor by grouping. That is the whole purpose behind factoring by grouping, is to factor out a quantity. So I'm going to factor out the 5x plus 4. I'm going to take it out. And when I say I'm going to take it out, it's like the opposite of the distributive property. What am I going to multiply to the 5x plus 4? Because here I'm going to do this. What am I going to multiply to that 5x plus 4 to give me this first term? Well, if I'm going to multiply 5x plus 4 times something to give me that, it's as if I'm actually dividing. So these are going to cancel out, and I'm left with an x squared. And now, if I think about it, 5x plus 4 times x squared is in fact x squared times 5x plus 4. And I'm going to do the same thing to the last term that I underlined over here. It's only one term, but it's a negative 1 times the quantity 5x plus 4. But I've already factored it out over here. So I have to think, what can I multiply to this 5x plus 4 here to give me that? And all that I'm missing is the minus 1. And so then this becomes the difference of squares, this one right here. X squared minus 1 is the difference of squares, which means I have two terms. I have a subtraction between the two terms, and both of these are perfect squares. So the square root of x squared is x times x. The square root of 1 is 1 times 1. 1 has to be positive and 1 has to be negative. And then I bring this one down, 5x plus 4. Again, we use the zero product property. So 5x plus 4 equals 0, x plus 1 equals to 0, x minus 1 equals to 0. That's where this comes down. And then I solved for x, and those are my roots.